So this is a video for the Calculus with Applications test review on area and definite integral. Number 1 says find the integral from 0 to 4. I'm going to mark off where 4 is. And it's asking then for the area under the curve. So I'm going to look at my scale. It's 1 by 1. So I'm going to count up my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and these two together make 10. So the area in number 1 is 10. Actually, hang on. The integral from 0 to 4 of the function is 10. In B, the area, which is the integral from 0 to 4, I notice now the scale is 2. So it's going to be 2 times however many blocks I count. 1, 2, 3, 4, stop at 4, 5, 6, 7, 8, 9, 10, 11. I don't know, these together maybe make 12 and a half. So 12 and a half times 2, 25. Use the tables below to find the integral by averaging the left and right hand sums. Okay, so the left hand sum, my x scale is 1, and left is these values. Right hand sum is going to be these values. This one's 110. This one is 74. So then the average is 92. And for B, now for the left-hand sum, starting on the left, but I notice my x scale is by 2. So I have to multiply by 2 to account for that rectangle width. Right-hand sum. Careful with your typing. Okay, so we get 50.6 for the left-hand sum, 61.4 for the right. So the average is 56. Illustrate the left and right hand sum until 4. Let n be 4. So that means the width of my rectangle will be 1, because if I need to go from 0 to 4 with 4 rectangles, each one will have a width of 4. So the right-hand sum, I start on the right-hand side to get the corner of my rectangle. Well, that is very squiggly. There we go. You get the idea. Then I'm going to go on the right-hand side at 3, the right-hand side at 2, and the right-hand side at 1. The left-hand sum, I'm going to stop at 4 again. I start on the left, on the left, on the left, and on the left. Use a geometric formula to find the integrals. So let's pull up my calculator again. I'm going to graph x plus 1. And make sure zoom 6. And we want to go from 1 to 4. Trace over to 1. I think I'm going to want to draw this. Hang on. Okay, I got some more space. All right, so for part A, we go from 1 to 4, 2, 3, 4. So I need these y values. This segment has a length of 2. Let me see, trace over to 4. This segment has a length of 5 from the y value. From 1 to 4, this is 3. We got a trapezoid. So a trapezoid is 1/2. Oh no, wrong thing, sorry. 1/2 the height, add up the bases. 7 times, so this is 21 over 2. All right, let's graph B. Semicircle. And this integral is from 0 to 2. So here's 0, here's 2. So this is a quarter circle. So it's a quarter pi r squared. And the radius is 2. So that's a quarter pi times 4. So that's just pi. All right, now we got C. (16 minus x squared under the square root). And this time the integral is from -4 to 4. So that's the whole half circle, half pi r squared. And 16 divided by 2 is 8 pi. Last but not least, we got 3 plus the square root 9 minus 2 squared parentheses. All right, so what do we got here? The floating semicircle. We want the integral from 2 to 5. Here's 2, 3, 4, 5. It looks like I've got this rectangle and a quarter circle. This is 3. Let me hit trace 5. So the end point over here is up 3. And then let's trace to 2. The endpoint up here is at 6. So if this is 3, then this segment is 3. We've got a rectangle, well, it's really a square, plus a quarter circle. So the rectangle is 3 times 3 plus a quarter pi. Here's my radius. That's 9 plus 9 over 4 pi. Without computing the integrals, decide if the function is monotonic, which means always increasing or always decreasing, and if the integral is positive or negative. Sketch a graph. Okay, clear. We've got y equals x squared. And we're going to look only from 0 to 5. So here's 0, 5's over here. So yes, part A is monotonic or monotone. It is always increasing. And from 0 to 5, all of the area is above the x-axis, so the integral will be positive. Okay, ln of x squared from 0 to 5. If this is not monotonic, we've got decreasing and then increasing. And from 0 to 5, all the area is above the x-axis. So again, the integral will be positive. Let's look at the next one. From 0 to 3. So from 0 to 3, the graph is monotonic because it's always increasing. But now for the area, I'm going to draw on this. From 0 to 3, it looks like the section under the x-axis is larger than the section above. So that would be a negative integral because more of the graph area is below the x-axis. Nope. Second ln, e to the negative x squared. I'm going to zoom in some. So zoom 4 is a nice window. And we want to go from -3 to 3. So this is not monotonic. We're increasing and then decreasing. And all of the area is above the x-axis. So that is positive integral. All right, number 9. Write a definite integral for the velocity. So for part A, the integral from 0 to 5 seconds of the function dt, because the variables are t. Sketch a graph. Let's type that in. We have to use x squared in the calculator, even though it's t in our problem. I went 0 to 5. So let me zoom back out, zoom 6. We're here, so it's going to go this. I'm just going to graph the whole parabola. And so to represent distance, I need to color the area under the curve from 0 to 5. So I'll say 5 is out here. Connect my parabola. You get the idea. All right, so we're going to shade in the area from 0 to 5. the area, oh man. The area under the curve represents distance. Okay, use your calculator to find it. So let's use the integral. So math, Fn int. If you have the newer kind, you fill in the boxes, and we get 66.6 repeating. And let's see, what's our unit? If it's feet per second velocity, the distance is feet. Use the calculator to calculate the integrals. All right. I got x squared in y1. Because I already had my integral information typed, I'm going to do second enter. Oh, it's the same bound, 0 to 5, so I'm good. We get 41.6 repeating. So if I just change my y1, I can keep using my integral notation here because it's referencing back whatever I have typed in y1. Now for this one, for number 12, I have to be careful. The integral is from 0 to 3. So I have to go back and change the lower and upper limit. And there are our definite integral values. Find the area of the graph and the x-axis between 0 and 6. So I already brought my graph over. You need to put this in y1. And area means the positive area of each section. So the piece, sorry, let me say that again. Area means the space taken up by each section. So the piece under the x-axis here, I need the absolute value of that integral. So for part A, I'm going to do the integral from 0 to 2. Let me just make sure that's the x-intercept. So let me go through my calculator steps here. In y1, I'm going to put the 1/2 x to the third minus 4x squared, 6x. And then the calculator has a calculate the x-intercept, but it's a lot of button pushing. I like to calculate the intersection instead. So if I graph y equals 0, which is the x-axis, I'm going to use a different part of my calculate menu. So I'm going to go to second, calculate. Instead of using the 0 for x-intercept, I'm going to use intersect, which is 5. I'm going to arrow over to this first x-intercept where it looks like they cross. I'm going to hit enter 3 times. And it tells me the intersection is 2. I'm going to do that one more time over here. Enter 3 times, and it's 6. All right, so that's nice. So our x-intercepts are the integral cutoffs, or the 0 to 6. So if I do 0 to 2 of my function, that part's above the x-axis, so I don't have to do anything to that value. But the part that's below, I'm going to have to take the absolute value of this integral, because the integral will be negative, meaning below the x-axis. So I need to take the absolute value. All right, so on my calculate screen, and I'm going to do that again from 2 to 6. Actually, wait, let me take math, enter, change that to a fraction. So 10/3 plus negative 64/3, but the absolute value would be positive 64/3. So when I add them together, I get 74/3. Part B says just find the integral. So I can go back and just do 0 to 6, get negative 18. I could have also done 10/3 plus the negative 64/3, which is negative 54/3, which is the negative 18 answer. Why are your answers different? Okay, so part A is a total area where the portion under the x-axis is a positive area value. Part B is a net area where the portion, the x-axis, is a negative value. Oh, and that, okay, so that's it. That's the end of the test review. Make sure you can do all of that independently and confidently before the test.